Good evening, everyone. I am RGB Habutay from Group 10, and we are assigned to report op art. So, let's start. What do you notice about these two pieces of art? This is what we call op art. Op art was an international art movement which came to prominence in the 1960s, exploring the ways abstract pattern, color, form can stimulate the eye. Op art is an aberration of optical art, and the term came into regular use in the mid-1960s. The style is characterized by abstract patterns, often in black and white, with stark contrast between background and foreground, resulting images to stimulate the eye and create sensation of swelling, warping, flashing, or vibration, sometimes causing unsteadiness and after image. The origin of term op art. Time magazine coined the term in 1964 in response to the work of French-Hungarian artist Victor Varésly, who is often referred to as the grandfather of op art. Time magazine coined the term op art in 1964 also in response to Julian Staczak's show's optical paintings at the Martha Jackson's Gallery, to mean a form of abstract art, especially non-object art that uses optical illusions. Works now described as op art had been produced for several years before Time's 1964 article. Pattern, line, optical illusion, and movement. Op art can be thought of as development from kinetic art. The question posed was how to provide the viewer with an illusion of movement on a static 2D surface. Exploitation of the fallibility of the eye through the use of optical illusion provide op artists with the answer. The use of repetition of pattern and line, often in high contrast, black and white, was one way op artists used to create the illusion of movement. The overall optical effect of the technique leads the viewer to see flashing and vibration, or alternatively swelling or warping. Riley's untitled diagonal curve is a good example of this technique, where black and white wavy lines are placed close to one another on the canvas, making the surface appear to shimmer and move before the eyes. Traditional perspective and depth. The separation of art from traditional perspective that began with Cézanne in the late 19th century allowed for the birth of the abstract and expressionist movement, amongst others, both important influences on op art. Movements such as these emphasize, or in many cases eliminated altogether, representation subject matter. Because of its geometrically based nature, op art is almost without exception non-representational. However, despite non-representational nature, the op artists made extensive use of the traditional perspective techniques originally developed to allow for the accurate representation of the natural world in art, in order to create the feeling of depth and space within their paintings. Victor Vasarely's Galaxies, in a classic example of the use of perspective in op art, with a centralized vanishing point creating the illusion of receding frame or lattice set in space. Color theory in the science of color. With op art came an acute awareness of the work done on the science of color and color theory. Color appeared to change depending on their proximity to other colors. For example, a red shape on a white ground appear much lighter than the same red shape on a black ground. Colors opposite each other on the color wheel when placed next to each other seem to be of different intensity than when placed some distant apart. These colors in the color range, blues, purples, and greens, are recessive and seem to sink back on the surface, whilst the warm colors, red, orange, and yellow particularly, are emergent. The manipulation of colors to achieve apparent movement is endless. Some colors placed next to neutral grays appear to create a new colors, an echo of color, an after image, and so on. The color relationship in play are known as simultaneous contrast, successive contrast, and reverse contrast, or assimilation. Op art and the science of perceptions. The phrase op art was coined around the time of the famous Responsive Eye exhibition, with op, of course, referring to optics, the physical and psychological process of vision. Work on the mathematical and scientific basis of perception had been ongoing since the 18s, with much progress having been made in the 1950s and 1960s, leading to a resurgence of interest in the field. The op artists, through their study of the science behind how the eye-brain work together to perceive color, light, depth, perspective, size, shape, and motion, were able to put into practice the scientific work around visual perception. Op art exploit the functional relationship between the eye, retina, and the brain. Certain visual stimuli can cause confusion between these two organs, resulting in the perception of irrational optical phenomena, something the op artists use to fall effect. A summary of influence and history of op art. We saw how linear perspective developed as the dominant force in the Western art, only later to be discarded. This is turn led to the Cubist experiment with form, Cézanne's work with color, and the abandonment of representational art entirely in the form of abstraction. From here, we look at the simple geometric shape of the Mondrian and Malevich, the anti-art of the Dadaist, the wild imagination of surrealists, the expressive freedom of the abstract expressionist, and the fascination with popular culture of the pop artist. In this part, we have looked at the influence of the simple geometry of the Bauhaus movement and the movement of the kinetic artists. We have also looked at how the scientific basis of perception and color developed and became better understood. So to answer the question as to what were the influences and origin of op art, the answer is hopefully clear.
Op art used geometric forms to create optical effects such as square, diamonds, triangle, and jitter. Op art also used abstract patterns and high contrast that excited and confused the viewer. A combination of technology, mathematics, psychology, and art. The foreground and the background of many pieces are difficult to discern. Op art gained mainstream popularity and was seen in advertisement, album covers, and fashion. The movement lost popularity by 1968, yet the optical styles and techniques are still present today. Op art is a visual art, also uses optical illusions. So what is optical illusions? Optical illusions is an illusion caused by the visual system and characterized by vivid perception and arguably appears different from reality. So there are three main types of optical illusion. First is the literal illusion. 2. Psychological illusion. 3. Cognitive illusion. So literal illusion is when the image you see is different from the images that make it up. For example, the illustration Hill created, which is actually two images strategically drawn to look like one fluid image, is a literal illusion. So the end result you see is a literal illusion is based on your perception. So number 2 is the psychological illusions. There are the effects of excessive stimulation of a specific type, such as brightness or color, such as an after image. So a common psychological after image is the dim area that seems to float before one's eye after briefly looking into bright light source, so such as a camera flash. So the third one is the cognitive illusion. Cognitive illusion is usually a picture that is meant to show and ambiguous image or images. These images can be meant to confuse the senses to require the mind to refocus attention to see both images. These kind of illusions are categorized as ambiguous, distorting, or paradox illusions. So optical illusions. So how do optical illusions work? Optical illusions happen when our brain and eyes try to speak to each other in simple language, but interpretation get a bit mixed up. So for example, it thinks our eyes told it something is moving, but that's not what the eyes meant to say to the brain. So we will show you a video on how optical illusions work.
Optical illusions are some of the most fascinating visual experiences to us as humans. Whether natural or man-made, they take our biological assumptions that we use every day to survive and turn them upside down. Take this one, for example. Keep in mind it's a still image. Nothing about it is moving. But then why do our brains interpret it as a moving image? This illusion fools our brain into thinking there's motion because of how our eyes move. While you may think that as you look around, your eyes move fluidly and smoothly, that couldn't be anything further from the truth. Our eye movements are actually pretty jolty, and it's those small, usually unnoticeable jolts, along with the lag in our brain's visual processing, that makes this image appear to move. If you focus steadily on the center of one circle, you'll notice that the image stops moving. This hypothesis was confirmed by a 2012 study from St. Joseph's Hospital in Phoenix, Arizona. Not every illusion works the same way, but nearly every one reverse engineers our biological presets. Take a look at this one. Which square, A or B, do you think is darker? The boxes are the same color. Researchers at MIT investigated this illusion and found the reason that it works to be twofold. First, our brains are trained to recognize patterns, and due to the checkerboard, we think that the squares should naturally alternate colors. Secondly, our brains inherently understand shadows, but in the case of images, shadows darken the color of the image behind it. With these two visual predispositions programmed into our brain, we're fooled into interpreting the image like we would any 3D object, but in actuality, the squares are the same color. Optical illusions as a whole draw on a few biological problems that we have too. Our visual processing only updates about every 1/10 of a second. This is actually incredibly slow, so our brains have developed methods of stitching our visual senses together to create a flowing image. Our brains do this so that we can kill prey for food or keep ourselves from getting hurt, but visual illusions exploit this time deficiency. Diverging from physical problems, our brain has also trained itself to recognize patterns, estimate light, and essentially to fill in the gaps to what our eyes miss. All of these skills work to our benefit in normal life, but illusions take these biological predispositions and reverse engineer them to trip our brains up. To our enjoyment, of course. Take this. It's called the Ebbinghaus illusion. Those orange circles, they're the same size. Our brains do this because they have developed a method to estimate relative size based on references around an object. This helps us recognize scale at great distances, but when thrown into a 2D image, our brain gets a little confused. Now look at this circle of pink dots and stare at the cross in the center. You'll find that after a few seconds, it starts to appear that as a pink dot is removed, a green one is put in its place. This all has to do with something called Troxler's effect. As the dots move in our peripherals, they become blurred and our brain isn't focused on processing things outside of our focus as fast. Along with this, as the dot disappears, since our brain is used to seeing the purple dot, when it's gone, it fills it in with purple's complementing color, green. In essence, green is the exact opposite of purple, so when it disappears, our brains fill it in with what it thinks should be there, as explained by Nature magazine. Why does this elephant look to have a ton of legs? Because our brains don't understand how to interpret the impossible lines in reference to our idea of what an elephant should look like. Why does this image look like there are black dots where each line crosses? Because our brains make assumptions about contrast and patterns when not in focus to help us stay safe. Why do these center lines look like different sizes? because the reference lines our brains use as scale distort its ability to measure the size of the center line. Every optical illusion exploits our brain's naturally evolved capabilities at recognizing patterns, filling in visual gaps, and otherwise helping us stay at the top of the food chain. While illusions may be fun to toy with, they actually help biologists and psychologists understand our brain to a deeper level than ever would be possible. So, next time you see an optical illusion, think of it as much more than just a fun image. It's a highly scientific trick designed to reverse engineer your biological assumptions. Thanks for watching.
Hello there, good evening everyone. Tonight, let's learn about op art. Op art stands for optical art that uses optical illusions. These are pieces that tricks the human brain into thinking something is happening that couldn't really happen in real life. The name op art was coined by Time magazine in 1964. The first op artist we want to talk about is Brigitte Riley. Oh really? Who is she? So Brigitte Riley, who was born in London in 1931. Her father was a printer who owned his own business. She didn't have much schooling until attending college, and as an adult, she worked in a glass workshop as an illustrator and as an art teacher. In 1958, she saw the work of Jackson Pollock and was inspired. She was also inspired by the scientific dot style of George Seurat. Around 1960 began her signature op art style. Some of the best known op art is black and white geometric lines and shapes that create the illusion of movement. Another op artist is Victor Vasarely. He often used colorful painting to make the 3D illusions by having clever uses of color or shapes that bend as if they're popping out of the painting. The next one is MC Escher. He was born on June 17, 1898 in the Netherlands. He was a sickly child who had trouble in school but was very good at art. In 1922, Escher went traveling and in Spain was inspired by the Moorish architecture at the palace called Alhambra. The decoration in this architecture are very geometric and it has tessellations. So, tessellation is an interlocking pattern that repeats with no gaps. At first, he drew very realistic art of the many places he visited, but he became more and more interested in the strange things you can do using math in art. He made impossible structures that twisted crazily in a way that wouldn't work in normal space on gravity. He uses tessellated design, and here are some of his famous and impressive recognizable works. In April 1966, Martin Gardner featured Escher's art in his mathematical game called in the magazine The Scientific American. Escher became famous with math lovers for his wild art that used math to bend the laws of physics. Another intellectual who did op art was Akiyoshi Kitaoka, who would make very bright, colorful, and almost hard to look at op art that tricks your brain with bright overlapping colors.